Today, we'll talk about finding continuity on a rational function. And the idea is, one, find the discontinuity by looking at really your denominator. Simplify the rational function first. In this case, we can cancel out the factor x minus 2. And by canceling that out, we know that at x equal to 2, we have a whole, which is a removable discontinuity. The remaining denominator is going to be your vertical asymptote. So we will have vertical asymptote at x equal to 4 and x equal to 6. We call this infinite discontinuity. So if we remove all of those discontinuity and only look at the interval where the function is continuous, then what we will have is that function g will be continuous on negative infinity to 2, because that's where your whole is going to exist. That's your first discontinuity. We don't include that discontinuity. So from negative infinity to 2, your function is continuous there. And then from 2 to 4, again, removing the discontinuity at 2 and the vertical asymptote at 4, then anything between 2 and 4 is going to be continuous. All right? And that's what we found. So today, we're going to take a look at one more example. We're going to look at example 2 right now. And it says, describe the interval on which the function f of x is equal to cosecant of x is continuous. So we want that one. Okay? So let's take a look at that example. So I got this diagram from the AP College Board video. And you're going to look at, and you're going to see, well, we're going to talk about these values in a moment. Okay? But let's take a look at where the function cosecant of x is discontinuous first. So let me ask you this, okay? What is another way to write cosecant of x? What is it? 1 over sine of x, right? So if you take a look at your little, I call it cheat sheet, and this is the one that I asked you to get. Cosecant is 1 divided by sine of x. So another way to rewrite cosecant is 1 divided by sine of x. Now, we know that this is a ratio, and therefore, if the denominator is 0, we're going to have an undefined function. And that's where our discontinuity occurs. So then I want to know, well, when is sine of x equal to 0? Yeah? And if you take a look here, this is your unit circle. Sine is the y value. So the y value is 0, at pi, 2 pi, and so on. Everybody okay? So this is where, in the video, they describe that. Well, sine is 0, at pi, at 2 pi, at 3 pi, 4 pi, 5 pi, and so on. Are we good? It's also true if we go backward. So if we go from 0 and we go clockwise, that's going to be negative pi, then negative 2 pi, negative 3 pi, and negative 4 pi, and so on. So you guys see that? So we know that x have to be equals to, well, notice each of these is pi. Do you guys see that? We start at 0. So then we can write this as n pi. Are we good? Where n is your integer. So at each one of these locations, that's when your sine at that angle is 0. Any questions on that? Are we good? Yeah? So then I know that my function is discontinuous. Discontinuous at these locations. Now, what kind of discontinuity? It would be infinite discontinuity. Is that good? So discontinuous at x equal to n pi. And what we're going to have is we're going to have that infinite discontinuity. And if you like, Ms. Ron, what is that? That's when your function has a vertical asymptote. Okay? So make sure you know that. So now, if I'm looking at the function is continuous on what interval, then you just have to exclude interval that have pi. Do you guys see that? So what I can say is, I can say that, well, the function is continuous on negative infinity. Or actually, we can say negative infinity because that's going to include everything else, right? So I think we can go for one of them. Let's go with negative pi, comma 0. So if I start from negative pi, I can go to 0. Anything in between, the function is going to be continuous. Yeah? So we just exclude the discontinuity. And then we can go, well, from 0 to pi, right? Or from pi to 2 pi, etc. Are you guys good? Notice in this case, we can't really write all of them because the function is going to spread on the left and on the right side. Do you guys see that? But the idea is the function is continuous on these intervals. Any questions on that? Are we okay? All right. That is it for 112.